Someone asked a question about 5 and 7 in the, this would be in counting methods, I believe. Just based on the question. And the example is n minus 3 factorial divided by n minus 4 factorial equals 12. Well, we want to make this equal to 12, right? So remember that a factorial, if I have n minus 3 factorial, I can expand that out to be n minus 3 times n minus 4 factorial. It's always going down by 1, which would be over n minus 4 factorial equals to 12. When I do that, I can divide out the n minus 4 factorial. So that tells me that, from that, n minus 3 equals 12. And then I rearrange and find that n is equal to 15. Now I can check that if I go back up. And if n equals 15, then this means I have 15 minus 3 factorial over 15 minus 4 factorial equals 12. So 15 minus 3 is 12 factorial, and 15 minus 4 is 11 factorial, which equals 12. Now you can either solve it right there with your calculator, or you can remember that what this means is 12 times 11 factorial over 11 factorial, which equals 12. And the 11 factorials will cancel out or divide out, and we get 12 equal to 12. So you have to do a little bit of algebra, oh no, to kind of sort that out. But it's all based on that principle that factorials are always going down by 1. So we can expand that out. So if you have something that is written as, say you have n minus 2 factorial over n minus 5 factorial, say you have that, well, I can expand n minus 2 to n minus 3 times n minus 5 factorial. Sorry, the factorial should be outside of the brackets on the bottom. My apologies. Over n minus 5 factorial. And once you get whatever, oh, sorry, I have to do one more, don't I? I skipped a step. This should be n minus 4 and then times n minus 5 factorial. Once you get it where you have the matching up top and bottom, you can divide them out. And then you would have your n minus 2 times n minus 3 times n minus 4, and then you would make it equal to whatever it was. And I mean, most of your test is multiple choice. So if you can't find a solution, you could always substitute in for n until you find the one that works. But it's really remembering that that top part expands out. That if this was written in numbers, if you had, for example, if you had 10 factorial divided by 6 factorial, and you wanted to reduce that, it would be 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial. You could expand both of them out and then reduce it, but why do that? Why, so that you're just left with 10 times 9 times 8 times 7. Okay, so it's a little bit of extension with our factorials. And there are a couple of questions on your quizzes and tests that deal with them. Not a great deal, but enough that you should know how to work with them.